Welcome to this explainer. Okay, let's dive right into this. You build a serverless checkout API. A user clicks Buy. The API spins, and after 30 seconds, it throws a 504 gateway timeout error. The user is frustrated. But 10 minutes later, they look at their bank account and realize their credit card still got charged. Why? Because you treated your API like a magic box, and you didn't understand how API Gateway actually invokes your Lambda function. Let me show you exactly what is happening under the hood. When you connect API Gateway to AWS Lambda, they communicate using a strictly synchronous invocation. API Gateway is making a live phone call to Lambda. It opens a connection, hands over the HTTP request, and then stands there, holding the line, waiting for Lambda to finish executing and hand back a response. When that request hits API Gateway, it passes through authentication and enters the integration phase. This is where the request gets prepared for Lambda. As an AWS developer, you have a massive architectural choice to make right here: custom integration or proxy integration. If you choose custom integration, you are taking the hard road. You have to manually write Apache velocity mapping templates. You have to write code inside API Gateway to explicitly pluck out the headers, the query string parameters, and the JSON body, and then map them into a custom JSON payload that your Lambda function expects. It gives you absolute control, but it is heavy and complex to maintain. But if you check the box for Lambda proxy integration, API Gateway does all the heavy lifting. It takes the entire raw HTTP request, the path parameters, the headers, the query strings, the source IP, and the body, stuffs it all into one giant JSON object called the event, and hurls it directly at your Lambda function. Think about that. Your Lambda function's event object instantly contains live web traffic. You just write event.queryParameters or event.body in your code, and you have exactly what the user sent. It is the absolute fastest way to build a REST API. But here's where people fail. They use proxy integration, their Lambda successfully processes a database rate, and then their code simply returns the string success. Immediately, API Gateway throws a 502 bad gateway error back to the client. Why? Because with proxy integration, you fired the receptionist. API Gateway is no longer formatting the response for you. It expects your Lambda function to return a very strictly formatted JSON object. To implement this correctly, your Lambda code must return an object containing an integer status code, a headers object, and a stringified JSON body. If you just return raw text, or if you forget to stringify the body, API Gateway panics, breaks the connection, and fails the request. You own the HTTP response now. Now imagine this. Your API triggers a Lambda function that processes a massive video file. The code works perfectly, but because the file is huge, it takes 45 seconds to run. Your API will fail every single time. Why? Because API Gateway has a hard, unchangeable, maximum integration timeout of exactly 29 seconds. Lambda functions can run for up to 15 minutes, but API Gateway does not care. At exactly 29 seconds, API Gateway will drop the connection and return a 504 gateway timeout to the user. But here is the DVA-C02 exam trap. Your Lambda function keeps running in the background. API Gateway severed the connection, but Lambda didn't stop. It finishes processing the video, it charges the credit card, but the user thinks it failed because they got a 504 error. This is exactly how you create duplicate transactions and corrupted system states. If your backend process takes longer than 29 seconds, you cannot use a synchronous API Gateway to Lambda integration. You must decouple it using SQS or EventBridge. Also, you must understand how errors propagate. If you invoke Lambda asynchronously, like dropping a file in S3, Lambda automatically retries failures twice. But because API Gateway is synchronous, there are no automatic retries. If your Lambda function runs out of memory or crashes, API Gateway immediately hands a 5xx server error back to the client. It is entirely up to the front-end client application to implement retry logic with exponential backoff. Finally, remember that cold starts directly impact your API latency. Because API Gateway holds the connection open, any delay Lambda experiences while initializing a new execution environment is directly passed to your user. If your Java function takes 4 seconds to cold start, your user is staring at a blank screen for 4 seconds. Let's lock this down. 3 rapid takeaways. 1. API Gateway invokes Lambda synchronously, holding the connection open and does not automatically retry failed requests. 2. Lambda Proxy Integration passes the entire HTTP request inside the event object, but requires your code to return a strictly formatted response containing a status code and stringified body. 3. API Gateway has a hard 29-second timeout, which will sever the connection and throw an error even if your Lambda function is still happily executing in the background. One final warning. Always catch your own errors in your Lambda code and return proper 4xx status codes for bad user input. If you let your code crash, AWS defaults to throwing a 502 or 500 error, making your system look broken and making it an absolute nightmare to debug in CloudWatch. So look at your own architecture today. Are you holding the line open on a 30-second process, just waiting for a timeout to happen?